for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's call. At that time, if you would like to ask a question, please press star 1. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn our meeting over to Ms. Catherine Hambleton. Thank you. You may begin.
Good afternoon. I'm Catherine Hambleton with NASA's Office of Communications, taking place at the agency's Stennis Space Center near Bay St. Louis in Mississippi. Green Run is a series of 8 tests and is a comprehensive assessment of the rocket's core stage prior to launching Artemis missions to the moon. This test is known as the wet dress rehearsal, during which engineers power up all the core stage systems, load and drain more than 700,000 gallons of cryogenic or super cold propellant into the tanks for the first time. Following the completion of wet dress rehearsal, NASA will conduct the final test in the series, called the hot fire test, during which all 4 engines will fire to simulate the stage's operation during launch. Here to talk with us about the wet dress rehearsal are John Honeycutt, SOS Program Manager at NASA's Marshall Space Flight Center in Huntsville, Alabama; Julie Bosler, SOS Stages Manager, also from Marshall; Mari Vander, Chief of Test Operations at Stennis; and Mark Nappy was not able to join today's call, but we can connect you with our Boeing contacts if there are any questions for Boeing that we are not able to address on the call. After a few opening comments from each of our speakers, we will take your questions. You can enter star 1 on your phone to be entered into the question queue at any time. Your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. We do ask that you please stick to one question and identify to whom your question is directed. About 1 hour after we conclude, you can listen to a replay of this teleconference by dialing toll-free 888-566-0691. That's 888-566-0691. So first we will hear from John Honeycutt. John?
Thank you, Catherine. Good morning, folks. It's good to be with you today. I'll give you a little bit of an overview where we are, and then I'm going to turn it over to Julie to talk a little bit more of the details of what's going on down at Stennis with the core stage. I will tell you that I'm extremely proud of the SLS team and the work and the progress that we've made on the core stage since we moved forward with Green Run. It's been an interesting year given the fact that we've had 6 storms to deal with in that area of the country, as well as the onset and the continuing challenges associated with the COVID pandemic. I was really excited yesterday to the administrator talk about the Artemis astronauts and the announcement that he made, unmanned spacecraft. I would remind you that at the end of the day, all the testing that we do relative to our qualification, certification, and verification validation for the rocket, at the end of the day, safety is of the utmost importance, and it's a big driver for us is keeping our astronauts and our crew safe. It's also been exciting for me to see us begin assembling the rocket in the vehicle assembly building at the Kennedy Space Center. We've got the aft booster assemblies placed on the mobile launcher, and we're proceeding with stacking those solid rocket booster segments. I would also tell you that we're not just building Artemis 1 rocket. We're continuing to get work done on all the rockets for Artemis 2 and 3. Those are well underway, with those core stages under construction at Temisha Assembly Facility, the work on the adapters, and the boosters for those subsequent missions continue, and the RS-25 engines are ready to go. So I think as Catherine alluded to, we're in the seventh test of a series, an 8-test series for the green run testing on the core stage at Stennis. We've got an extensive test program that's really going to wring the rocket out to test both the hardware and our operations, which will ensure mission success for our first launch of the Artemis vehicle. There's more than 30 first things happening. 700,000 gallons of cryogenic propellant into the tanks for the first time. The wet dress rehearsal is extremely important because it gives the team not only a chance to load the propellant and see how the hardware performs, but it also gives the team knowledge and insight as to how the vehicle operates and allows us to fine-tune and practice our procedures before we move into hot fire. So this week we started the 7th of 8 green run tests, and that was what we call the wet dress rehearsal. We did load some propellants into the tank. We ran into some operational challenges associated with loading the liquid oxygen, and you'll hear more about that in this call today. The team, I would say, and me standing on the sidelines watching, was extremely professional, and they had all the processes in place to move into a safe configuration for the vehicle, and then we ultimately decided to take a pause and look at making some changes operationally as to how we load the propellants. And so the team's been busy working that for the last couple of days. Our team is still laser focused on delivering the core stage. We're not going to rush through any of this testing. Our end goal is mission success and astronaut safety. Right now, I would tell you that we're on a path to get through, to get back into the wet dress rehearsal and get to a hot fire test probably no earlier than the last week in December. And that would be followed by a delivery to the Kennedy Space Center in the February timeframe. And we're still on track to support a November Artemis 1 launch date. So right now I'm going to turn it over to Julie Basler. Julie is the SLS stages manager, and she's going to tell you a little bit more about what we did on Monday in the wet dress rehearsal and some of the things that we learned. So Julie?
Okay, good afternoon, everyone, and thank you, Mr. Honeycutt. So this week, the SLS, Boeing, and Stennis team, we had a really valuable opportunity here to practice our propellant loading operations and really monitor how our core stage is going to respond when it was exposed to these cryogenic fluids for the first time. I just want to remind everyone, core stage is a brand new design and development, and it will provide significant thrust for us to do all the future missions for the Artemis program. So it's really important for us to understand this hardware, and as Mr. Honeycutt said, really to ensure it's a safe vehicle so we're able to fly astronauts on it. So on Monday, the team successfully loaded a limited amount of liquid hydrogen. It was cooled to minus 423 degrees Fahrenheit. We had no issues with this operation. All the data looked really good on it, and it really provided us an opportunity to see how the tank and the main propulsion system reacted with the fuel loaded. it actually decreased one of the risks we had going in for this new design and development. So it was to get this hydrogen tank partially loaded for the first time. So that was a big milestone for the team, and everything looked really great there. We saw no leaks on this first load. Also on Monday, we began loading the liquid oxygen. And the temperature in the system, that when we were monitoring it, it was not getting down to the levels we needed to meet our temperature requirements. So this was during the slow fill tank load operations when we were doing the monitoring. The team decided to pause and look at this closer. So we took a couple hours on Monday to see if we had any opportunities there to move forward. And as Mr. Honeycutt mentioned, given the condition of the vehicle, we wanted to ensure we got into a safe configuration. So we decided to close down on the liquid oxygen part of the tank filling that on Monday. This was the first time, again, that LOX was flowed from the facility to the core stage, and it's the first test of our LOX propellant loading as an integrated system between the facility and the core stage vehicle. So where we are today is we are reviewing some changes. So we're in the process of implementing those changes to ensure that we are able to reduce the temperature on the LOX side during this initial start of loading in the core stage. And this is utilizing existing Stennis facility infrastructure. So it's really just a procedural update that we're making at this time. The integrated NASA stages, Boeing and Stennis teams, we're completing our analysis right now just to make sure we thoroughly understand how this new procedure will work. And then we'll take in the next couple of days and we'll define the final schedule for the next wet dress rehearsal attempt. Right now, it is looking like it will be next week. So we're getting the team all ready and getting all of our procedures updated to support that. We will post an update on the Artemis blog as soon as we have defined the exact date for the start of the wet dress rehearsal again for our second attempt. After wet dress rehearsal is complete, we'll need several days to analyze the data and determine if we are ready to move forward with hot fire testing. We also will be replenishing all the fuel and the commodities, which are pretty significant to, get the facility ready for this kind of test, but also to conduct the test. So we're doing that also this week. So we'll have the plan for the start of the hot fire test right now will be towards the end of December, and this will support delivery of core stage from Stennis to KSC in February of 21. So this is the first time, we've tested this core stage, which is going to fly on Artemis 1. So we are going to take every opportunity to ensure we get the most out of this test. This testing is not only, important for us to understand how the core stage responds, but it also gives us a lot of valuable data for ensuring our verification and validation efforts are complete, so we can COFR the hardware as part of our NASA flight readiness reviews. So with that, I'm going to turn it over to Mr. Maury Vander, the Stennis Chief of Test Operations.
Well, thank you, Julie. As you mentioned, I'm the Chief of NASA Test Operations at Stennis, and I've got a group of engineers that work with me, and we're part of the operations team that has been part of the entire green run activity from start to finish, from the loading of the vehicle onto the test stand and all the subsequent tests that have come along with that. This team has been it's been an integrated team with NASA Stennis, NASA Marshall, Boeing, Aerojet Rocketdyne, and our S3 contractor. And as John alluded to earlier, they faced many challenges over the past year. We've had storms and we've had COVID impacts, but they've done nothing but overcome all those obstacles as they went along the way. And it's an honor to be associated with them. This group of engineers' primary focus during wet dress and hot fire is to provide the core stage, the gases and propellants it needs to make it through our wet dress rehearsal and our hot fire test. So it's a large undertaking, and as we've heard from the previous two speakers, we've got amazing amounts of propellants that are needed to make that happen, as well as helium and nitrogen gases as well. It's an extremely challenging operation, but this team is up to the task. Like I said, we're primarily focused on operating the facility systems to provide gases to the core stage, as well as recording instrumentation and video along the way, to allow that evaluation of the core stage performance to occur, and to make sure we're ready to ship this thing to KSC in February and for a subsequent launch. And with that, Captain, I think that's all I've got to say so far. So thank you.
Thank you. We'll now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered in the queue at any time, and you can enter *2 if you would like to be removed from the queue if your question is already addressed. So the first question we'll take from Jeff Faust of Space News.
Artemis 1 launch on schedule for November 2021. Thanks.
Yeah, Jeff, thanks for the question. So we're getting to a point where we've got very little margin left in the schedule relative to our commitment to our delivery date. We've been working closely with the KSC folks relative to the operations that they need to execute in order to get the core stage and the rest of the SLS rocket ready to fly in November. I will tell you that I'm managing to an internal management date, trying to get the core stage to delivered sooner rather than later. But with the issues that we've come up with associated with the storms and the COVID and the margin that we had built into the schedule for the green run, that's getting pretty slim. Now, with that said, I've got a high level of confidence that once we overcome this operational challenge that we've got with the liquid oxygen system, that the team will be able to swiftly execute through the wet dress rehearsal and get into the hot fire.
Thank you. Our next question is from Eric Berger of Ars Technica.
Yeah, hi. Thanks very much for doing this. My question is for John as well. I was wondering if you could clarify the timing on the stacking of the solid rocket boosters. Is there a clock that starts ticking on their viability when you've completed them on the mobile launcher? I think I've heard the number of 12 months that they need to be used after being fully stacked, but I don't know if that's true or not. Just wondering, sort of, if you stack them now, you're committed to launching by next December, or you've got to unstack them, or whatever needs to be done. Just some clarification. Thanks.
Yeah, thanks, Eric. That's a good question. You are right that we've got a stack life of 12 months on the boosters. We're working with the EGS team at KSC relative to the timing as to when we start the stacking activities. Obviously, the clock doesn't start until we stack the next segment on the aft segments. We do believe that we could extend that stack life requirement, and the team's actively working that. But the key thing to note today is we're meeting with KSC folks in the EGS and their leadership team on a regular basis as to when we want to pull the trigger relative to stacking. Right now, I think once we get through the wet dress rehearsal, we'll be able to give the green light to go ahead and start the stacking.
Thank you. Our next question is from Bill Harwood of CBS News.
Sure, who this is for? Probably for Julie. I don't really understand the issue. Can you give us some sense of how much LOX got into the tank? what the temperatures were that you saw. And I am confused as to whether this is a rocket issue, a GSE issue, or both. If you could clarify that, I'd appreciate it.
Yes, I can. So thanks, Bill, for the question. So it's really an integrated issue between the facility and the core stage. So this is the first time we were transferring the locks from the facility to the core stage. We were using modeling, and we did verification of that effort prior. But we were actually just a few degrees difference than what we wanted to see coming in. And it's really important that during the initial phases of the filling of the tank, so we were wanting to see the requirement is about 169.1 Rankine. That's negative 290.57 degrees Fahrenheit. So we didn't quite get there on Monday. What we saw at the temperature for the interface to the core stage was 173 Rankine, which is negative 286.67 degrees Fahrenheit. So we're just a few degrees different. So we wanted to ensure this was an operation that gave us the temperature that we needed going into the core stage. So it's really an integration issue. Looking at the core stage and the amount of the heat that it had in it. We want to get this right for the first operation going into the tank. So we filled up just enough to pass the phase where we knew we weren't going to be able to get the temperature to a level that was going to be acceptable to meet the requirement, and that's when we paused in the testing.
Hey, Bill, this is John. I would add, back in our shuttle days, we did quite a bit of testing relative to loading the space shuttle in a test program down at Stennis. We did something similar to that with what we called an anti-geyser test. And so the thing that the team is trying to protect and the limits that got tripped are relative to the concern of developing a gas bubble in that long 17-inch column, which is the feed line, which could end up collapsing, and then you could have quite a bit of energy release when the liquid oxygen above that bubble could release and flow back down the feed line. Does that help?
I think so. Bill, if you need additional clarification, you can rejoin the queue. Thank you, John. Our next question will be from Philip Sloss of NASASpaceflight.com.
Thanks. Just following up with what Bill was asking about. Can you? I assume this is for Julie. Where are you measuring the temperature? Is it at the cutoff sensors inside the vehicle, or somewhere between the barges and the umbilical plates? And this is a dual position stand, and I know they do periodic tests of the R68A engines on the B1 side. So is it somewhere in the B2 plumbing, or I know you said procedural, but can you just provide a little bit more clarification on exactly why you couldn't get the temperature you wanted?
Yes, so thank you, Philip. So it's really at the valve at the interface is where we're measuring the temperature. And what happens is when it's coming off the barge, it's going through the lines there, and they're all we have heat protection on those, so we're not going to lose a lot of the cooling coming through the lines. And so when we got it to the valve going into the core stage is where it was actually measured at. Again, we're just a few degrees difference, and we think it was just a part of the integrated modeling, and capturing the exact temperature and the heat load that we were receiving off of the core stage.
Julie, I think we ought to let Maury take a shot at that one too.
Well, the systems basically that we use for R68 on the B1 side is the same system that we're using here, to a point, to our level 7, and then it branches in two different directions. We've got the pump on the barges that supply the locks, and they perform best when they're running basically, I'm gonna say wide open at 1,000 GPM or so. We're operating a little bit below that, and with that slower velocity, I think that may have had a little impact on the temperature.
Yeah. I would just to add to that, what I would say, like what Mari said, is if you imagine this really cold LOX flowing through this facility line, there's obviously going to be some heat input into it, and we go through a process to condition the tank during chill down and slow fill, where we have a requirement to flow at a slower rate. And so that gives the liquid oxygen a much better opportunity to pick up the heat.
Thank you, John. That's a good way to put it.
All right, thank you. Our next question is from Mark Carreau of Aviation Week.
Thank you very much. If the wet dress rehearsal goes well, or when it concludes, how much time do you need before you can go to the hot fire? Is there a kind of an estimate?
Yeah, Julie, you probably ought to take that one.
Yes, I can take that one. So our plan right now is it's about a 2-week turnaround from wet dress to hot fire, but that's really contingent upon reviewing the data. So as long as we get a clean wet dress and have get all the data that we need to close our verification items out, it'll be on a 2-week time frame.
All right, thank you. Our next question is from Tariq Malik of Space.com.
Hello, yes, thank you. I think I have a follow-up on the timing from wet dress to the hot fire for Julie. I'm just kind of curious, once you have the core stage fully loaded, how long do you plan to keep it in that wet dress rehearsal, like fully fueled? Is it just a nominal countdown phrasing, or is it kind of dynamic where you might keep it fueled shorter or even extended than an actual launch? Thanks.
So yes, as part of the procedure that we have laid out, for wet dress, we have a 2-hour hold in the procedure, but it all happens within the same day. So right now we're looking at, we start about 6 a.m. in the morning, getting the team ready. And then around 4 or 5 p.m. in the afternoon is when we're actually, look at towards the end of the hold period itself. So it's a pretty long day, but we do have a 2-hour hold in there, and that's really just to help us to understand for launch operations how long we can hold, and that the system can accommodate that requirement.
Thank you. Our next question is from Jared Frankel of the National Space Society.
Yes, my question is for John and or Julie. Will there be any more tests like this on the future stages, or will those all go directly to the Space Center?
Yeah, this is the only stage that will go through the green run test in the hot fire. All the subsequent stages will go from MAF to the Kennedy Space Center.
Thank you. All right, next question is from Zach Hall of SpaceExplored.com.
Hey, thanks for taking the question. This is for anyone who can answer. Can you kind of describe the fix for controlling the temperature? So I've got a pretty good understanding now of what was not on target the other day, but just kind of curious about what's the process like for in between now and reattempting fueling.
Yeah, so let me answer it, and then I'm going to turn it over to Mari, because he's working closer with the team that actually goes off and does the execution. What I would tell you is the team's doing a thorough review and looking at what the options are. We've got the best cryogenic experts in the country that are part of this team, and they're in the process of working through that right now. So, Mari, if you can share any details there, go ahead.
Yeah, thanks, John. We're looking at our overall process. How can we do it a little bit better? Can we utilize the system in a little bit different manner to deliver cryogenics at a lower temperature? And as John alluded to, we've looked at that the last couple of days, investigating some possible improvements to make, and trying to go down the path of implementing some of those. So we may actually we're actually getting close, I do believe. So we may actually get a chance to demonstrate that sometime soon. So we're just kind of working through the process, trying to find a process improvement.
Thank you. Our next question, we'll take another question from Bill Harwood of CBS News.
Yeah, hi, thanks. And this is, again, just clarification on this. And I'm not sure who it's for, but I don't understand if this is a problem that could possibly require physical modifications to the rocket, whether that means insulation, et cetera, of the valve system, or is this more a matter of getting the ground support equipment and all that plumbing and everything leading up to the rocket, adjusting that somehow to get the temperature where you want it before the LOX enters the tank? Just trying to understand if this is something that could possibly require modifications to the booster itself. Thanks.
Yeah, Bill, this is John. There's not anything wrong with the rocket. This is an operational activity associated with how we load the liquid oxygen, and I've got a high level of confidence that the team is going to be able to work the fix, and it's going to have to be on the ground side to do that.
Thanks. Our next question, we'll take another question from Philip Sloss of NASASpaceflight.com.
Thanks. I assume this is for Julie. Are you looking at any procedural changes in the tanking timeline for the next attempt? And then for the full wet dress, do you have to go all, the countdown, do you have to count down all the way down to 33 seconds, or can you take something less than that to proceed into the hot fire test? Thanks.
Yes, thanks, Philip. So our plan will be to go down to the 33 seconds. If some of the analysis that's being conducted right now is looking at with the new procedure to ensure we can do the 2-hour hold. If we have to reduce the time period in order to make sure we have enough locks available, we would likely reduce that 2-hour hold, is where we would get some margin back if this new procedure requires us to have more commodities available to do this earlier part of this procedure. And if we've also looked at how far in the count do we have to go down before we could go into hot fire, and we could if we have an earlier cutoff than 33 seconds, that is not an issue necessarily. It really depends on why we had to cut off early. So that will be part of the discussions we would have with all the technical authorities and with our program office to ensure we're ready to go. But as long as we can get the majority of our verification and validation data out of the wet dress rehearsal, we'll be good to go into the hot fire.
Thank you. Our next question is from Joey Roulette of Reuters.
Quick question for John Honeycutt. I just wanted to follow up on the LOX issue. What do you mean by operational? What does that mean? And what changes would need to be made in those operations to be able to get the LOX temperature where you guys want it? Thanks.
Yeah, thanks.
John, let me help you with that one a little bit. We're looking at things. We may wind up having to flush those lines more often just to make sure that we can keep them conditioned as we go along, which, as Julie alluded to, may require us to use a little bit more LOX in that initial phase of chill down, and could affect the the 2-hour hold. But what we think we can do is operationally, by cycling valves and, doing some things differently on the supply, we think we can deliver the liquid oxygen at a temperature that the rocket requires without any facility modifications to the system that exists.
Thank you. All right, we'll take another question from Eric Berger of Ars Technica.
Yeah, hi again. Probably for John as well. I'm wondering what your general expectations are, especially with regard to the hot fire test coming up in a few weeks. This is new hardware, complicated system, very big fuel tanks, and you really never know what's going to happen until you actually fire a launch system up. John, do you have some personal expectations? Like, one former shuttle program manager told me he thought there was about a 25% chance of a near perfect test. About a 50% chance of something, going wrong that's going to take a few months to fix, and then maybe a 25% chance of something more serious than that. So I'm just wondering kind of how you think the core stage is going to come through these last two tests and what it's going to take to get it ready for flight.
Yeah, thanks, Eric. So I'll tell you one of the things, Eric, that was at the top of my worry list and has been there for a long time, given the experience and the history that we've had with dealing with hydrogen leaks in the shuttle program, was running into a problem where we were chasing a hydrogen leak. Coming out of this abbreviated test that we did on Monday, I have a lot more confidence in the system in and of itself, because we wetted with liquid hydrogen all the potential areas of concern that I thought we might have. And we've got a seal that's I think it's in the 4 to 6 foot diameter range. It's at the bottom of the liquid hydrogen tank. That was one that I have been keeping my eye on closely. The team did a really good job with the test program, and the data that we saw coming out of the test showed that system performed in an excellent fashion. Another one that was probably pretty high on my worry list that has gone down is the avionics system and how it's performed. And during the testing that we did on the first 6 test series, we learned a lot about the subsystems and the ability for the control system to operate the rocket. And in the wet dress rehearsal that we did on Monday, there were no issues there. So from what I've seen, Eric, my confidence has gone up significantly. I think we're at a point now where we're likely to see some small things that may have to go work. But I think the team's done an outstanding job, and we've learned enough to know that in all likelihood we're not going to have a big issue that causes us to stand down for any significant amount of time.
Thank you. Our next question will be from Zach Hall of SpaceExplored.com.
Hey, this is probably for Maury. When we go to hot fire test, what are some key things that we're looking at there? So if you were to break down that last step of the test into smaller steps, what are the things that you're looking at in the 8 minutes, and what should we expect to be? What defines success in that?
Well, for us, we're the facility supply system, so we're going to deliver gases, we're going to deliver the propellants, we're going to do everything that we can do to give the rocket to get the rocket in the position where it's ready to fire. So roughly 5 minutes before the actual firing, our job should be, I'm not going to say over, but it's going to be a lot less stress. Well, there'll be a lot less involved. We'll have the rocket fueled, ready to go. We'll be watching some facility systems on the the water, the deflector water, and things such as that, to make sure that we stay where we need to. And once the thing starts firing, I guess I'm going to see if I can hold my breath for 480 seconds, because it should be something to see. But you'll be observing, cameras looking for fires, watching data. But as they've talked about, this rocket seems to be doing a good job so far. And they've got, we have confidence that they've got the appropriate red lines to prevent anything from going wrong. So it should be a heck of a ride.
Thank you. That's definitely a long time to hold your breath. All right. Our next question, we'll take another one from Joy Roulette of Reuters.
Hey, thank you. Question for John or anyone who could answer. I was just wondering if any of the issues or struggles with Boeing's supply chain have impacted any of the SLS schedule, and what those kind of struggles or issues might be, and how NASA has been stepping in to maybe help them out in any way. Thanks.
Yeah, Julie, you want to answer that one?
Sure. Yes, I can take that one. So for core stage 1, for what's in the stand right now, no issues at all with the suppliers. We had great support from VACO working when we did have issues going on with some of our pre-valves. So everything's been very, very good there with the suppliers. For core stage 2 and core stage 3 hardware that's currently in development and production, all the suppliers, some of these are kind of small mom and pop shops, and when they have issues with the COVID, with the pandemic, that's really where we're seeing some of the impacts. So, we're really working. Boeing's doing a great job working with these suppliers to see how they can help them, when they do have impacts from some of their engineering community, especially. But we are seeing some supplier delays due to COVID. But we're working through those issues, and some, part of it is we're just resequencing some of the work if the hardware, isn't able to arrive, when originally planned to continue, so we can continue on with the development and production of the hardware. So not seeing any huge impacts right now, but it is something that we all watch and ensure that we're helping our suppliers. To make sure that, the COVID pandemic does not have a long-term impact on the program.
Thank you. We'll take the next question from Jared Frankel of the National Space Society.
I guess this is more for whoever it's just relevant for, but when they were talking about the testing earlier in the year, there was more mentions of a long refurbishment period after the stage was tested, that it was going to be possibly sent back to Michoud, I think. And I'm wondering what caused the refurbishment period to shrink, or if you guys are going to be refurbishing it at all before you send it back to the Space Center for stacking.
Yeah, so I'll answer a little bit of that and let Julie add on to it. The areas that, relative to refurbishment, I think that we've been keeping a watch on are primarily associated with the thermal protection system, which is the foam that's on the insulating foam that's on the core stage. The team's done a great job of relative to their process control, as well as doing testing to learn about how the TPS performs at cryogenic temperatures. What we do know from our history from the shuttle program is any sort of TPS damage that could occur, and what I mean by that is any kind of cracking or in the TPS or anything like that. Usually, from our experience, it shows that we only see that and learn that during the first cryogenic cycle that the test article or the core stage would see. At this point in time, there are no plans to ship the core stage back to the Michoud assembly facility. I would also tell you that we've been working closely with our partners at KSC in the Exploration Ground Systems program to transfer knowledge and train their workforce as to how to do TPS application and TPS repair. So, Julie, if you got anything you want to add there, go ahead.
Okay, no, those are all great points, John. The only other thing I will add, we're also working with Aerojet Rocketdyne on, the drying of the engines. That's a very procedure we do have to do complete before we leave Stennis and ship to KSC. So Boeing's working very closely with Aerojet Rocketdyne on that, and actually understanding a little bit more what we can do there. So we're actually seeing some improvements in the amount of time there that schedule is. So, some of this is really just laying out the specifics and the details and seeing how we can do a lot of the TPS work that Mr. Honeycutt talked about in parallel to the Aerojet Rocketdyne, engine work that we have to do before we can ship. So that's all coming together very, very well, and we understand that process very well right now.
Thank you. We'll take one more question, and the last question will come from Philip Sloss of NASASpaceflight.com.
Thanks. Just hopefully a quick clarification from Julie. For the 2-hour hold, we heard that was going to be after the cutoff and recycle, but I just wanted to confirm that. And then can you guys give us a no earlier than date for the next attempt? We were hearing Sunday. Thanks.
So Philip, I guess I'm not real sure. So the 2-hour hold is as part of our procedure before we do the detanking. So that's kind of where it is in the process flow to make sure that we can, see, if we have to go into a hold before we would fire engine. So that's where it's in the procedure itself. I'm not sure if that answered the question or not, though.
All right. And thank you much. Thank you all for joining us today. That will conclude our call. You can listen to a replay of the teleconference in about an hour by dialing toll-free 888-566-0691. Again, that's 888-566-0691. The replay will be available for 30 days. And the SLS rocket and the agency's Orion spacecraft will be the backbone of NASA's Artemis program to take human exploration farther into space than ever before. To learn more about NASA's Artemis program, including updates to the Artemis blog and on wet dress rehearsal and green run hot fire testing, follow our progress online at nasa.gov/Artemis program. Thanks again, and have a great day.
Thank you for everyone's participation. This now concludes today's conference. All lines may disconnect at this time. Speakers, please stand by.